It's time for us to talk about value types versus reference types. And I think the best way to do this is to go through examples, get a little bit confused, and then start defining things, instead of defining things and then going through the rest of the process. Because it won't really allow you to fill in the gaps the way it would allow you to fill in the gaps if you are confused and also interested and engaged by an idea, which is why I want to show you the examples first and then give the proper definitions afterwards. So let's go right into it. I will create another method here saying static void change number. And this will take an int, and we'll say a, and then we will say a equals 90. All right. And here in my main method, I will say a, initialize, declare a, and then initialize it saying it's 10. And then I will say, all right, I want to use the method change number, and I want to pass an a into it. And then I want to print a. Let's see what happens. So I'll put it right here. So let's go over this real quick. A is 10, right? We have created an integer variable. We declared it, initialized it with 10. So we have assigned 10 to it. Then we passed it into this method. So 10 is here. And then we say, or rather a is here, which is supposed to be 10 when it gets into this method. And then we change 10 to 90. Okay? And then we get back into main. And then we print a. My question to you is, what do you think a will be? Will it be 10 or will it be 90? Let's see. As you can see, a is 10. So that's interesting, right? Because it begs a question. Why didn't it change to 90? And that's a very, very good question. But before I give you an answer, I want to show you one more example. I've already created a custom type called person. You can see it here. It's just class person, and then I have first name and last name in it. These are properties. We'll talk about what properties are a little later, but you already know about classes, so I will not give you an introduction about that here. So we have that custom type, and now I will say change name. I will change the name of the method and call it change name. I will change int to person, and I will say person to change, and this method name will be different. I will actually create a person here. I will say person, and I will say person, and then new person. Okay. The person will have first name John, and the person will have last name Smith. All right, great. And then let's pass person into change name. Let's use change name method and pass in the newly created person object into it. And at the end, let's actually print out person first name and also person last name. All right. So in here, I will say first name equals Jane. And then I will say person last name equals Doe. How about that? So this is great. So the question to you, once again, is now we have a new custom type. It's person. we changed some stuff on it, right? It has two fields, so we changed the first name and the last name. We could have just changed the first name, but we decided to change both. We passed it into the method, and we changed it here. We're not returning anything. And then we're printing the properties. Pretty similar to our previous example, right? What do you think is going to happen? Do you think that it will say Jane Doe afterwards? Or do you think it will say John Smith afterwards? Let's give it a shot. And now, as you can see, it says Jane Doe. So it was able to change the properties, even though in our previous example, it was still the same number after it got back from the method. So the method didn't really have an effect on it. So what do you think is the difference? And the difference here is that this is the fundamental difference between value types and reference types. Now that we have seen the examples and we are pretty nice and confused, it is time for us to fill in the gaps by going over the structures and learning about formal definitions and the differences. So this was our very first example, right? You remember we had in our main method, we said that A is going to be equal to 10. Then we had another method where we said that change number is going to have A equals 90. So before we even talk about the difference, let's talk about the main structure. So let's step back a little bit and look at the entire structure. You see, there is something called call stack, and then there is another thing called a heap. So one thing you need to know is that whenever you're running your programs in C#, there are two regions of memory available to you to store your data, because whenever you're running your program, you actually store your data in the memory. And these are the regions where you store them. One is known as the call stack, another one is known as the heap. A call stack is actually designed based on the stack structure, stack data structure. So a stack is a data structure, and you know what data structures are. They're just a way for us to be able to organize data. But a stack organizes data in a very particular way. So we already know about lists, and stack is just another data structure. So in a stack, whenever we're putting elements, we're actually pushing them down, and as we're putting more elements into the stack, we're actually putting these elements on top of the existing elements. Think of it as a stack of plates, stack of papers. So in this case, if the stack was empty, first we would have had main, and then when we're putting another thing onto our stack, we put it on top of the existing item. So that would be main. And change number would come on top of the main, right? So you can say that change number was the last item entered, and the main was the first item entered, based on how it is organized. There are also two things to know about a stack. Whenever you're putting things into a stack, you call those pushing. And whenever you're taking things out of the stack, you call that popping. So when you're putting things into the stack, let's say you put main into the stack, you pushed it into the stack. Whenever you put change into the stack, change number into the stack, you pushed it into the stack. Now, if you get rid of the change number, you would pop it out of the stack. And that's exactly how you would do it. You would first take change number out, and then you would take out main, instead of taking out main and then change number, right? So you would put things in and then stack other things on top of it as they come in. And whenever you're taking things out, you would take the very first item out of the stack, which in this case would be change number. So now we know about the call stack and just the stack data structure. Let's talk about the heap now. A heap is basically a chunk of memory space that uses pointers to reference memory locations that are currently in use. We'll talk more about heaps, but in this specific example, we actually don't need the heap, and you'll find out why in a little bit. So let's get back to the example now. We have our call stack, and within the call stack, we have our main and the change number. So the call stack creates an item every time a function is called, and the function will have its local variables within it. So main has its a, which was 10, and then change number has its a, which equals to 90. But here's the kicker. Since a was an integer, and an integer is a value type, we save that onto the stack. An integer is not the only value type. There are also other value types that you already know. For example, bool, double, decimal, those are all value types. These are things that are inherent in the C# language. So it's not something that I came up with, it's just something that is part of the language. So these are value types. And whenever we have a value type, we save it in the stack. So we push it onto the stack. So in this case, main, which was the method that was called initially, because that's the entry point into our application, that was pushed onto the stack, and main had a variable that was called a, and a was initialized to 10. So that's great. It has its own scope, and it was sitting on the stack. Then we called the change number, which created another item onto the stack. It pushed it onto the stack. And that method has its own a, even though we passed in an argument a into change number. What happens here is that a got into change number, and it says, okay, that's great. I'm going to change your a that you passed into me into 90. And then after this method was complete, it was popped out of the stack. So basically this happened. So you see, once it came back to main did not know what the change number of a was any longer because it was gone out of the stack. It no longer exists. So that's why we saw a to be 10, even though we changed it in the method above it, because that method was gone and that value was gone with it. Now let's actually take a look at the other example where we have used a custom type person, but in this time we actually were able to change the values. So see, in this example we're actually using the heap. So classes are reference types. That's why when we created our person class and we instantiated it, it was saved onto the heap. And we had our first name and last name. Initially, it was John Smith. And then we had our method main, and within that method, we have a pointer, which was the person. So we have instantiated the person class inside of our main method. And you remember how I told you that reference types are being saved in two regions of the memory, one in call stack, one in the heap? Well, that's exactly what I mean. The pointer is saved onto the stack, but the actual data is saved onto the heap. And the pointer is pointing from the stack to the heap. So it's pointing to the actual data. So once again, main is pointing through the person pointer to the heap, which has the person data. And it has John and Smith. Then we went to another method, which said change name. And we passed in to it the person pointer. And in this case, we named it person to change. But it's still the same thing. It's still the same pointer. So we passed in the pointer as opposed to passing in the actual data. So once we got to change name, this was still pointing to the same exact spot in the memory. And in here we said, let's change first name to Jane, and then change this to Doe, right? And then once this method was complete, it was popped off the stack. There you go. And it came back to main. Now the person is still pointing to the same address in memory. However, this data has now been changed. it's been changed to Jane Doe. And this is exactly why we saw it changing the second time around. And this is the fundamental difference between value types and reference types.